Now let's try to sketch another one, right? So this one says sketch f at x is equals to x cubed minus 6x squared plus 9x. Okay, so in this case I'm gonna start with the turning point, okay, but remember you can still start with the y-intercept, then x-intercepts, and then turning point. So me, I'm just starting it from the bottom. So the turning point, how do we get the turning points? We find the derivative of f, or the derivative of that equation, and then we equate the derivative to 0. So this is what I did here, and then once it is at this stage, good people, remember you can use the quadratic formula, but I just decided to divide everything by 3. Then after that I got my x is 1 and x is 3. So what do these things mean? Remember, these are the x coordinates at the turning points, okay? These ones are the x coordinates at the turning points. So I can look at my a here and confirm that the a is positive. It means the graph is shaped this way, right? This is how the graph is shaped. Now I know that on my graph I'm gonna have two turning points, which is this one and that one. So the first turning point will have x as 1, the second turning point will have x as 3. But the question is, what are the corresponding y values and how do I get them? Remember, we substitute in the x values into the original equation. When I substitute f as 1, I get 4. Remember, f of 1 is equals to 4 means when x is 1, y is 4. F of 3 is equals to 0 means when x is 3, the y value is 0. So it tells me that here I'm gonna have 4 when x is 1. Here I'm gonna have 0 when x is 3. So we have our turning points there. Now good people, we now need to find our x-intercepts. Okay, now that we have the turning points, we need to find the x-intercepts. Now remember, to find the x-intercepts, right, to find the x-intercepts, you let y equal to 0, meaning where you see y you put 0. Remember, this is y, so you're gonna say 0 is equal to x cubed minus 6x squared plus 9x. Good people, on this case here, there's no need to use the synthetic division method. The synthetic division method is advisable when you have the equation in the form of ax cubed plus bx squared plus cx plus d. Okay, so when you have all the 4 terms, but here you just have 3 terms, isn't it? So you can just take out a common factor, especially when you do not have d. Good people, I suggest that you don't use the synthetic division. But if you have d, right, let's say you do have d there, right, let's say you do have d, but maybe you do not have b, like you have something like 2x cubed plus 3x minus 6. In this case here, you have d, right? So you can use the synthetic division, but remember that this, you need to rewrite it as 2x cubed plus 0x squared plus 3x and then minus 6, so that the terms are always 4. Remember, for that thing here, for this thing, you always need 4 terms. So you're gonna have here 2, you're gonna have 0, you're gonna have 3, and then you're gonna have negative 6. They must always be 4. Then here you would have your x is equals to something. Remember, you can check the previous video for more details there. Alright, so I hope that is clear. So in this case, we are not going to use synthetic division. Simply what we are going to do is take out this x as a common factor. Okay, so if we do that, we'll have 0 is equals to, if I'm going to take x out. There are 3 of them. If I take one of them, I'm left with 2. What about here? If I take 1x, I'm left with 1x. Here, if I take 1x, I'm left with what? 9. So then I say, therefore, this should be equal to 0, or whatever is in the bracket, right, which is x squared minus 6x plus 9, it should be equal to 0. Okay, then I just solve for x in terms of this one here. So I'll say my x is 0, or here I'm gonna open 2 brackets, then I have x and x, right? Then I have negative 3 and negative 3. So therefore my x will be 0, or if I equate this bracket to 0, I'm gonna get x as 3. If I equate this bracket, I'm gonna get x as what? 3. Basically this and that are the same coordinate. Okay, so what is the meaning of us having, or rather getting an answer like this, whereby this bracket gives us 3 and then the second bracket also gives us 3? This means that this, whenever you see something like this, good people, I need you to know that it means you have only two x-intercepts. Okay, number one, you have only two x-intercepts, which are this one here, right? X is equals to 0. When x is 0, remember the y is always 0 for x-intercepts. Y is always 0. Then when x is 3, right, y will be 0. So these are the only two x-intercepts, because this and that is the same number, so you only have two x-intercepts. And then I need you to know that it means at that x-intercept that is repeating, that is also the turning point. Okay, all the time it's like that. At that x-intercept that is repeating, it is also the turning point. So let's remember that this would be the turning point, right? This would be the turning point there. It's always like that. So now we have our x-intercepts, isn't it? So what are we left with finding? We're left with finding the y-intercept, which is the most easier one, isn't it? So what I'm gonna do is that, since it's very short, I'm just gonna do it here. So for the y-intercept, right, what do? You just let your x be 0. So where you see x, you put 0. So you're just gonna say f of 0 will be 0 cubed minus 6 into 0 squared, and then plus 9 into 0. Okay, the answer is just 0. F of 0 is 0. So what does it mean? When x is 0, your y is what? 0. That is your point. So let's collect all the coordinates that we have so that now we can sketch, right? So all the coordinates that we have so far, remember, for the turning point we had two coordinates, which is 1 and 4, 3 and 0, right? So let's write it here. For the turning points, right, for the turning points we had 1 and 4, then we had 3 and 0. Okay, that was for the turning point. And then for our x-intercepts, right, for our x-intercepts we have 0 and 0, right? Interesting. We have 0 and 0, and then we have 3 and 0. Okay, then we have 3 and 0. Then for the y-intercepts, right, for the y-intercepts, just remember what we got there. We got 0 and 0, right? So you always collect them like this, good people, right? Then let's remember, what is the equation of g? It's or f of f, it's x cubed minus 6x squared plus 9. So f of x is x cubed minus 6x squared, is it plus 9x, right? Let's just double check that. Minus 6x squared plus 9. Okay, that is it. That's correct. So your a, what is the value of a then? The value of a is positive, is greater than 0, right? Is a positive or negative? It's positive. So when you sketch your graph, this is what you simply do, good people. You know that a is positive, so it means the graph has this shape here. You just draw it, good people, freehand in your book. Then now you know that you have a turning point here, and then you have another turning point there. Simple procedure as last time, good people. You check your turning points. Which one is here? Which one is there? You have two of them, 1 and 2. Which one? The x value is smaller here, so it means this is the one that should start. That is on the left. Then the one that is bigger is the turning point on the right, right? So the one that is bigger would be the turning point on the right here, 3 and 0. Okay, 0. So what about the x-intercepts, right? The x-intercepts, how many are they? How many are our x-intercepts? 1, 2, isn't it? We have 2 x-intercepts. So having 2 x-intercepts, what does it mean? It means now we're going to have our line, which is the x. Remember, x-intercept is x-axis. So I should have my x-axis. So is my x-axis going to be like this? No, if I do it like this, it means my x-axis is cutting the graph at 1, 2, 3 points. It means I have 3 x-intercepts. Do I have 3? No, I have 2. So if I have 2 x-intercepts, what do I do? This is very, very easy, good people. Look at one of the x-intercepts. It's 3 and 0, right? Remember I told you that if an x-intercept is repeating, it is also the turning point. Do you remember that? I said if an x-intercept is repeating, it is also a turning point. So check. It means when I draw my line, my x-axis, okay? It means when I draw my line, which is my x-axis, my line must also pass through the turning point like this. My line must also pass through the what? The turning point like this. Then as you can see, the graph will then touch this yellow line will touch the graph at only 2 points. Okay, so you always do that, good people. Okay, you just make sure that the line touches one of your x-axis touches one of the turning points. That's it, good people. That's as easy as that. Just make sure that one of the just make sure that your x-axis touches one of the turning points. Okay, then you will have your 2 x-intercepts. So it will be this one. It's already written, right, because it is also a turning point. And then here it would be 0 and 0. Okay, so this one here would be 0 and 0, this point here, because that is our second x-intercept. What is our y-intercept? It's also 0 and 0. So if our y-intercept is 0 and 0, it tells you that it is also at this point. So it means that our line, our y-intercept should be looking like this, right? So this should be our y-intercept there, right? It should be like that. It should also be passing through this point because that is the line of 0 and 0. So this is your y, that is your x. Then you are done, good people. Okay, then you are done. That is the equation. That is your graph of f at x. Beautiful, isn't it? That is the procedure, good people. If you follow this procedure I'm giving you, you can never go wrong. So all you do is that first of all you start with the turning points. Then after that your x-axis must touch. You count how many x-intercepts you have. If you have only 2, then the x-axis must touch one of the turning points, then cut the graph. It can touch here and then cut the graph, but in this case it touches here because you have 3 and 0 and 3 and 0, and then it cut the graph. Then your y-intercept will just be this line there. All right, so will just be this point. So now that is it, good people. What are we gonna do right now? We're gonna look at some of previous papers and then see if we can answer them now that we know that, right? We're gonna look at one question here and then see if we can answer and apply what we have learned so far. Right, let me try to make it a bit small. So this is what we have here, right? We have a question here, right? You can try it out, good people. You can try it out, and then after that we can look at the solution. All right, so this is what we have, and then it says write down the coordinates of the y-intercept of f. You are given that this is f here, right? So this is your f there. They want the y-intercept of f. How do we get the y-intercept of f, good people? 9.1. To get the y-intercept, remember you just say let your x be 0. Where you see x, you put 0. So you're gonna say f of 0 will be 0 cubed, and then minus 0 squared, and then minus 0 plus 1. Okay, so essentially f of 0 will be equal to 1. So your y-intercept is when x is 0, y is 1, right? X is 0, y is 1, right? Then 9.2. 9.2 says calculate the coordinates of the x-intercepts of f. Okay, remember now, how do we get x-intercepts, right? For 9.2, to get x-intercepts, remember, you're gonna say let your y be 0. Where you see y, you put 0. So this is your y. So you're gonna have 0 is equal to x cubed minus x squared minus x plus 1. Now, good people, if you have something like this, I need you to know that, remember, we're gonna need synthetic division because we have 1, 2, 3, 4 terms. So we're gonna use synthetic division method. That's why it's 5 marks there. So remember, how do we apply synthetic division method? I'm gonna have my table there, right? Then on my table, I'm gonna say I have x and then I have y. Then I'm gonna have negative 3, right? Negative 3, then I'm gonna have negative 2, then negative 1, then 0, then 1, 2, and 3. Then I start substituting my x values into f and see what are the y values I'm getting. So for the first one, right, what I'm gonna do is that I'm gonna just say f of negative 3 would be negative 3 cubed, right, and then minus negative 3 squared, and then minus negative 3 plus 1. Then I just put that in the calculator, good people. So I get negative 32. Okay, I get negative 32. It's not the one I'm looking for. I go and then I now substitute here 2, negative 2. Then I substitute negative 2 now, negative 2. So if we make it negative 2 there, right, we then just put it in your calculator, good people. The answer that you get is negative 9. It's still not 0, right? We keep going. Now put negative 1, okay, in your calculator. Just put negative 1 there, you get 0. Voila, that is the one that we want. So we want this one. So our x is negative 1. Okay, this is what we want here. Our x is negative 1. All right, so now that we have that, we stop there. We stop there. There's no need of going forward, good people. You completely stop there. Let's remove this, and then now you continue, right? You stop there, and then you go and draw your what do we call it? Is it a hill? Yes. So you're gonna do this, right, and then you're gonna do this, right? You're gonna do this, I think, and we're gonna do this, and then you're gonna do that, right? So now we're applying synthetic division there. So now remember, our x is negative 1. You write it here, x is equals to negative 1. Then here, remember, you write 0. Okay, then what do? You go here, remember that this is your a here, right? Then here it's your b, here it's your c, and then here it's your d, right? You write down those coefficients. So you have 1, you have negative 1, you have negative 1, you have 1. Then what do? This one you drop it. Remember, there is a plus here. This one you drop it like it is to be 1. Then after that, you say what is 1 times negative 1? The answer is negative 1. Then you say what is negative 1 plus negative 1? It's not 0, good people, because positive times negative is negative, so that will be negative 2. Then you say what is negative 2 times negative 1? That is positive 2. Then you say what is negative 1 plus 2? That is 1. Okay, then you say what is 1 times negative 1? That is negative 1. Then you say what is 1 plus negative 1? 1 plus negative 1 is the same as saying positive times negative is negative. 1 minus 1 is what? 0. Then you know that you did it correctly. Then remember, you open your bracket. This is your a, so you're gonna have 1x squared. This is your b, you're gonna have negative 2x. This is your c, then you say plus 1. Ax squared plus bx plus c. Then you open another bracket here. Remember, if x is negative there, you put it as positive inside the bracket, then you say is equal to 0. Okay, so now that you will have something like this, good people, remember that here is just saying that you have x squared minus 2x plus 1, and then here you have x plus 1, you have x plus 1, which is equal to 0. So therefore your x squared minus 2x plus 1, the first bracket will be equal to 0, or your x plus 1 will be equal to 0. So here you can use the quadratic formula to get the answer there, right? It will be what? So you can use that, or but I'm just gonna quickly factorize this. So I'm just gonna say you have x minus 1 and then x minus 1, right? Or your x plus 1 will be equal to 0. So what does this mean? Remember, this means that x minus 1 will be 0, or x minus 1 will be 0, or your x plus 1 will be 0. So you get that x is 1, or x is 1, or your x is negative 1, which means negative 1 and 0, which means 1 and 0, and the same as 1 and 0. So here it's repeating, right? Once it's repeating, you can we can leave it like that, but take note that how many x-intercepts do you have? How many do you have? Therefore, remember, you have 2 x-intercepts because the other one is repeating. And remember, this one that is repeating there, it is also a turning point. It's also a what? A turning point. All right? So you have your x-intercepts, 2 of them. You have 1 and 0, you have negative 1 and 0. Then this one here is also a turning point. All right, so but you would have gotten your 5 marks there. Then you have answered that question. Then they say calculate the coordinates of the turning point for 6 marks. You see now, that is exactly the same thing we were doing. So now we're going to calculate the coordinates of the turning point. So to get the coordinates of the turning point, remember that I think that would be 9.3. Yeah, it's 9.3. So to get the turning point, remember, you just need to find the derivative of f. F is equals to x cubed minus x squared minus x plus 1. So you just say the derivative of that will be equal to 3x squared minus 6x minus 1. Okay, so you equate the derivative to 0, remember, because at turning points the derivative is always 0. The gradient is equals to 0 at the turning points. So you then solve for you then use quadratic formula there, right? Let me see if it's possible to get it through factorization. We can say 1 1. No, it's not possible. So you need to use the quadratic formula there. Remember, your a is 3, b is negative 6, c is negative 1 there, right? So you are gonna get that your x is negative 0.15, or your x is 2.15. okay, your x is 2.15. Now that you know the x values of the turning points, right, remember, since your a is positive, your graph is looking like this, right? So now we're gonna get the corresponding y values, right? So how are we gonna get them? We have to substitute these x coordinates in the graph, because remember, you have 2 x turning points, 2 turning points. This one will have negative 0.15, because remember, the smaller x value is on the left all the time. We don't know the y value. Here, this one is going to be 2.15. We don't know the y value. So we substitute that into f. So we're going to say f of negative 0.15 would be negative 0.15 cubed, right? Then you say minus negative 0.15 squared. Okay. And then you say negative 0.15 minus negative 0.15 and then plus 1. So here the answer will be, so the answer should be 1.12, right? Okay. And then you then find for that, so you say f of 2.15. Just don't make a mistake of substituting in this equation. It must be in the original equation, okay, to get the y values. So you're gonna say 2.15 cubed and then minus 2.15 squared minus 2.15 plus 1. The answer should be 4.17. Okay, so now you know that for this one, what does it mean? Remember, it means that when x is negative 0.15, the y value is 1.12. So it means here we have 1.12. And then here, what does it mean? When x is 2.15, the y value is 4.17. Perfect. So now we got our turning points, okay? So you would have gotten that 6 marks from there. Imagine, just for getting this, you get 6 marks. Nice stuff. Now sketch the graph, clearly indicating all x's and the turning points. Now the fun part. This is the part I love the most, good people. The part of sketching this graph. I'm not even gonna lie to you. I love it so much. I don't know why I love cubic like this. No, maybe I know why. Maybe it's because it starts with the letter C. Anything that starts with the letter C, I fall in love. So now, what are our turning points, right? Let's write here. Remember, we always need to write these, to list them before we can write. So our turning points, we have them here. I'm just gonna copy them first. So our turning points, you have negative 0.15 and 1.12, right? Then you have 2.15 and then you have 4.17, good people. Then what is our x-intercepts, right? What are our x-intercepts? Let's remind ourselves. We found them to be what? To be 1 and 0 and negative 1 and 0. So we say 1 and 0 and negative 1 and 0. Then our y-intercept, what was our y-intercept, right? Remember, we got our y-intercept on the first question. The y-intercept was 0 and 1, okay? It was 0 and 1. So we write 0 and 1, right? Now, interesting enough, good people, there is something that is happening here. I assumed that this would be also the turning point, but look, the turning points are completely different. Well, you know that we learn every day, so it means let's remove that ideology there, right? Let's remove that ideology. It's quite interesting. I never expected that we can have x-intercept that are repeating and then one of them is not a turning point. This is quite a turn of events, I don't wanna lie. I never expected that. I'm hoping we didn't do anything wrong. I'm hoping we didn't do... we did something. Oh my goodness. I was too fast. I am very, very sorry, good people. Look at here on the derivative. Why did I get negative 6, good people? It should be negative 1 times 2, which is negative 2. Yo, Clyting. How many times did I call you Clyting? So you should have negative 2x there. Yo, my goodness. Yeah, it just didn't seem right. So it's actually like this, okay? Then you can then, wow, would need to start afresh on this. And you know, good people, please bear with me. These videos, I maybe, you know, as time goes on and then we have some good machines, maybe I would be able to edit them. But for now, I'm not able to edit anything, right? So please bear with me. So let's just fix that real quick. Okay, my sincere apologies. So we would have this, and then we can factorize. That would be 3x, and then that would be x, and then we'll have 1 and 1. So there it should be, and then is it negative x there, right? Let's also check that. Let's also double check that. Yeah, it should be negative 2x minus 1. So yes, it's negative 2x minus 1. So okay, good people, you can just quickly use the quadratic formula there. So if you use the quadratic formula, you'll get that x, right, your x would be 1, or right, or your x would be negative 0.33. I hope you're already seeing the mistakes we do in the exam when we are panicking or when we are rushing. Okay, so now let's fix that real quick. So it means we would have to get f of 1 instead of that. So f of 1 would be 1 cubed minus 1 squared minus 1 plus 1. Okay, so that answer there will be 1 minus 1, which is 0, and then 0 there. So you get 0, okay, as your f of 1. It means here when x is 1, y is 0. Okay, so you have 1 is to 0, and then you substitute f of negative 0.33, right, by saying negative 0.33 cubed minus negative 0.33 squared minus negative 0.33 plus 1. Okay, what answer do we get there? So you put it in your calculator, so you would get your answer as 1.19. So it means here when x is negative 0.33, you would get 1.19. And actually these things are vice versa. This point is there and then that point is there, okay, because of that error, but it doesn't really, okay, it matters, okay. So but then the main point is that we should write them correctly here because we want to sketch, isn't it? So we should write them correctly here. So you would have here, remember the turning points, now it's 1 and 0, right? And then you have negative 0.33 and 1.19. Okay, so this is what we have there as the coordinate. Now as you can check now, right, the x-intercept that is repeating this one, it is also the turning point. Do you see that? It's also the what? The turning point. Now it's true, right? Now it's true. You see this and that are the same. So now we can sketch, right? Now we can sketch, and then now remember that A is positive, isn't it? From the graph, A is positive. So good people, this is what we do. Remember, you just do this. Remember, it's gonna increase first, then decrease, and then it's gonna increase again. This would be our graph there. Then remember, we now plot our turning points, right? So in terms of our turning points, we look at the x here, and then look at the x there. Which one is smaller? It's this one, right? So it means this one here should be negative 0.33 is to 1.19. okay, then what is the next? Then this one would be 1 and 0. This would be 1 and 0. Then now in terms of our x-intercept, remember we need the x-axis. So our x-axis, how many do we have? We have 1, 2. We have 2 x-intercepts. It means our graph must touch. Should we cut it like this? No, because it would be 1, 2, 3 x-intercept. No, we can't do that because it will be 3 x-intercepts. We have 2, right? So what are we gonna do instead? Oh my goodness, this thing, right? So instead we are going to make sure that our x-axis touches one of the turning point. It should touch this one because that is the turning point. So our x-axis will touch this one, and then after that it will proceed to cut the graph at the other point. So that is what we have there, right? So we can say this here, right? We can say this here is the x-axis, and then this one is the other x-axis, then this is our this x-intercept. So remember this one, it would be -1 and 0, right? Because we already have 1 and 0, so this one will be -1 and 0. Now we need the y-intercept, right? So look at the y-intercept, good people. What is the x value of the y-intercept? Remember, we focus on the x. It's 0. So where is 0? Is 0 between -1 and -0.33, or is it between -0.33 and 1? Yes, it should be here. So good people, because it's between this and that, you just draw a straight line. Even if it's in the middle, it's fine. You just draw a straight line. Then you then say this, and then you say that. Then that is your y-axis, good people. It means that this point here would be 0 and 1. Okay, that would be 0 and 1. So remember, 0 is here, right? Then that will be 0 and 1. Then that's it, good people. By just doing so, you are done sketching F. It's beautiful, isn't it? I love it so much. Okay, so please watch out for more videos on this. I will be posting more videos on cubic functions, looking at some interpretation problems. We have only covered how to sketch them. Now we need to interpret them, right? So that will be on the next video. Please be on the lookout, good people. Happy learning. And please watch the whole calculus playlist. The link will be in the description, and then you can check out more videos on calculus. All the best.